Alright, hi everyone, welcome to this quick look video on the air and atmosphere chapter. Right, this is pertaining to pure chemistry students only. Alright, because there's some additional info that is not found in combined science camp. Now, for this video, right, let's take a look at the big ideas in air and atmosphere first. Right, so the first big idea is the constituents of clean air. What exactly is inside clean air? Secondly, air pollutants. Thirdly, acid rain. Fourth, depletion of ozone layer. 5. Carbon cycle. And 6. The effects of greenhouse gases. Now, let's take a look at the first component. In terms of the constituent of clean air, right, students are required to understand that within air, a mixture, there's actually multiple different gases, right? And you can see over here, there's different composition over here, right? And of course, the main thing is to know how to apply this concept to questions rather than just memorizing the figures, like how many percentage, and just regurgitating out, right? So it's important to know how to apply it to different kind of questions. Now, as you attempt the 10 series later on, you'll see how it brings relevance to this particular pie chart. Do take note that the components of air can actually be separated by using fractional distillation of liquefied air. This is because the different gases have different boiling points. Now, in terms of air pollutants, right, we are required to understand what exactly are the sources, the effects, as well as solutions to these air pollutants. Now, there are a few air pollutants that are of interest to us, mainly carbon monoxide, unburned hydrocarbons, oxides of nitrogen, which can refer to NO as well as NO2, sulfur dioxide, methane, as well as ozone. Now, all these can actually be found in this particular YouTube link, which provides a quick summary on the air pollutants, how they come about, and what are their effects, right? And of course, in your textbook, as well as in your notes, that's where you can retrieve back how to solve the issue that's caused by these pollutants. As we move on to the other components in this video, you realize that we'll come back to these solutions as it transcends through the different key ideas of this chapter. So I would like to emphasize again, if you are still not very sure about the sources, effects, as well as solutions to these air pollutants, please click on this link, or rather follow this link, and go to this video called Science Bracket Chem Air. It's still applicable to pure chem students as well, whereby you can take a look at these very interesting infographics on what exactly are the air pollutants. Now, in terms of the third big idea, which is on acid rain. Acid rain refers to rain that has a pH below 5, right? Because our normal rain that we have on a day-to-day basis is already slightly acidic. But in chemistry, what we are concerned about are rains that are of pH lower than 5, because that will be considered harmful to various organisms as well as structures. Acid rain is mainly due to nitrogen dioxide and sulfur dioxide. Just a recap, these are your acidic oxides. So how did acid rain arise? Now, when you have nitrogen dioxide or sulfur dioxide in the air, they can actually combine with oxygen as well as water in the atmosphere. Now, we know that during rain, as the water mixes with all these different gases, it can actually generate acids, as you see over here, right? So you have your nitric acid as well as your sulfuric acid. Now, when these two were to fall onto us, onto surfaces, onto organisms, that's when they cause problem. So what are some of the harmful effects? Now, they are of great danger to aquatic life, right? The fish and other plants that's within the water, because this rain can change the pH of the water and then affect their ability to survive. Buildings that are made of limestone, especially, as well as metals, right, can go through corrosion if acid rain falls on them. Because if we recall from what we learned in our previous chapter on acids and bases, we know that acids can react with carbonate, acids can also react with metals, and that's where they form the relevant products, right? When there's a reaction, it will mean that you're actually corroding buildings that's made of limestone, which is calcium carbonate, or buildings that are made of metals, such as bridges or structures that's made of metals. At the same time, it's also important to note that when rain falls on the soil, right, it actually changes the pH of the soil, making it a lot more acidic. Now, plants, they actually have a preference, different plants have a preference of different pH to survive in. Now, when the soil becomes too acidic, it actually hinders the ability for the plant to survive, and as a result, the plants might die. Right, so these are just some examples of harmful effects of acid rain. In terms of solution, how do we resolve the problems that comes about with acid rain? Firstly, let's say that acid rain has already occurred, right? What we can do is to add what we call slacked lime, right, which is calcium hydroxide, to the soil for neutralization. Now, calcium hydroxide is a form of alkaline, and with by adding it into the acidic soil, neutralization can happen. At this time, I just want to connect back to something that we learned in acids and bases, which is that alkaline can actually react with ammonium salt. Now, what is the relevance over here? Okay, so we know that slick lime, calcium hydroxide, is a form of alkaline. And what we need to take note of is that ammonium salt are actually often used as fertilizers, so they are often being applied to soil. Okay, so if you were to add in an alkaline such as calcium hydroxide with the fertilizer that contains ammonium salt, you actually result in a reaction that produces salt, ammonia gas, as well as water. Now, and that is actually not beneficial to the plant, because the ammonia that's formed, right, will carry the nitrogen and escape into the environment. Then the plant will lose out in the nitrogen. Right. This part, if it's too confusing for you, please post the question down using the QR code, and I'll try to explain it clearly the next time. Some other solutions. First and foremost, we can, in fact, instead of treating the issues caused by acid rain, let's not burn fuels that contain sulfur, right? By not burning fuels or burning fuels that have very little sulfur, we can avoid generating sulfur dioxide. The third method, flue gas desulfurisation. Now, this method requires the use of large-scale industries setup, right? And as the name suggests, they are trying to remove the sulfur from the gas. Flue gas actually refers to waste gas that comes out when you are burning fossil fuels, right? So flue gas refers to waste gas that comes out, and they often contain sulfur dioxide. So desulfurization meaning that you will pump the flue gas into this chamber, right? Within this chamber itself, there will be a reaction that happens to form this solid that's called calcium sulfide. Now, calcium sulfide will further go through reaction to eventually form calcium sulfate, which can then be used by different manufacturers for different kind of products. So what exactly happens is that the sulfur dioxide that enters the chamber will actually interact with the calcium carbonate. So inside this chamber, what we have is that sulfur dioxide as well as the calcium carbonate will interact within this chamber, and the reaction generates what we call calcium sulfide, right? Not calcium sulfate. So this is calcium sulfide, CaSO3. At the same time, there's carbon dioxide that will be released out. Now, the next step of this process is that the calcium sulfide, right, CaSO3, will further go through oxidation because there's oxygen in the air, and then it will form calcium sulfate. Now, calcium sulfate can be used as a raw material for other processes, right? So that is where we try to generate useful substances from pollutants. Now, the fourth method, right? We have talked about 3 methods so far. The fourth method is actually to use catalytic converters. Now, catalytic converters are often found in vehicles, right? In fact, right now I would say that maybe 95% or 99% of all the vehicles that we have are actually vehicles with catalytic converters, right? That is to ensure that we reduce the amount of air pollutants that comes out. As we learned in the earlier part of these notes, there's a lot of different types of air pollutants like carbon monoxide, nitrogen monoxide, unburned hydrocarbon. Now, all these can actually be generated when you're burning fuels. So when vehicles burn fuels inside their car, right, they actually generate these 3 different types and even more of pollutants. However, we cannot release these air pollutants straight out into the atmosphere because then we'll be polluting the atmosphere. So what we do is that by using this device called the catalytic converter, which contains transition metals known as platinum as well as rhodium, right, you can actually bring about a series of redox reactions that helps to turn the harmful gases into clean gases, right? So that's what you see over here. Now let's take a look at a video to have a better understanding of how a catalytic converter actually works.
Things in here act as a catalyst to help convert your emissions to make them safer. You see what I did there? Catalytic converter. All right, so what's in here? There's ceramic. That doesn't react with anything, but it gets super hot, and it stays super hot, so the reactions can happen. If you're going for an emissions test, make sure your catalytic converter is hot. Next, there's rare metals, platinum, palladium, and rhodium that react with the emissions. They're each worth about $30 a gram, and there's between 3 and 7 grams of them in a catalytic converter. So that's why people steal them. But the metal in a converter is worth about as much as a catalytic converter, so don't be a jerk. First is a reduction catalyst. Platinum and rhodium pull oxygen off the nitrogen atoms, so the nitrogen gets shot out as benign N2, the way it came in the first place. The second stage is an oxidation catalyst. Platinum and palladium use the oxygen molecules in the exhaust and the freed up oxygen from the first stage in two ways. First, it helps bind them to the carbon monoxide to get CO2, the same stuff you breathe out. And second, this stage converter will oxidize any unburnt hydrocarbons as they pass through.
And so as you saw in the video, within the catalytic converter, right, a series of reactions can actually happen, right, and most of them involve some form of redox reactions. Firstly, carbon monoxide can go through oxidation with the help of the catalyst as well as oxygen to form carbon dioxide. At the same time, the catalytic converter can also combine two pollutants, which is nitrogen monoxide and carbon monoxide together, and to form a clean gas of nitrogen as well as carbon dioxide escaping out. Last but not least, it is also possible for any form of unburned hydrocarbon, this is just one example, CaH8, to combine with oxygen with the help of the catalyst, eventually giving you the carbon dioxide as well as the water. Now, you realize that the purpose of the catalytic converter is really to use catalysts to convert harmful gases into less harmful gases, right? And of course, do take note that although we are trying to remove pollutants, be mindful that you're actually generating carbon dioxide as well, which has an impact on the environment. Now, coming to the fourth big idea, in this chapter, we also talk about the depletion of ozone layer by what we call CFCs. Now, CFCs are chlorofluorocarbons. So, chlorofluorocarbons, right, are a form of substances that is widely used in the past, be it in refrigerant liquids, in aerosol sprays, etc. But with some changes with environmental laws, with a protocol, as well as a lot of innovations, right, we have actually moved away from using these chemicals in our daily products, right? But in the past, when people are using these products, what happens is that we actually release a lot of CFCs into the atmosphere, and this CFC, right, in the presence of any form of UV light, will actually result in decomposition of the CFC into chlorine atoms. Now, the chlorine atoms, right, will then continue to react with ozone, as a result, breaking apart ozone into oxygen. So what you see over here is that it's actually a two-step process, whereby firstly, the chlorine atoms can react with ozone to form this compound over here, as well as oxygen. Then the chlorine compound will then further react with more ozone to form chlorine, as well as oxygen. So overall, right, if you look at the whole equation, what is actually happening is that the ozone has been broken down into oxygen. So as we learned in primary school or in geography, right, we know that the Earth is surrounded by a layer of ozone layer. And the ozone layer's job is to help us protect us from UV ray, right, from the sun, so that it doesn't reach us. But with a hole in the ozone layer, this allows UV ray to enter in, and so as a result, this can result in issues such as skin cancer or genetic mutations. The fifth concept in this chapter, pretty straightforward, is the carbon cycle. Now, the carbon cycle requires us to know what exactly are the processes naturally that can release carbon dioxide, which is respiration as well as decomposition. And the process naturally that can remove carbon dioxide is photosynthesis. Now, why am I emphasizing on naturally? Because I want you to realize that in a normal natural world, right, it is alright for carbon dioxide concentration to fluctuate. However, the problem comes in when we have man-made activities that requires a lot of combustion, such as generating electricity by burning fossil fuels. Now, combustion has released so much carbon dioxide at a rate that we have never seen before, that we are actually resulting in other environmental issues. Now, the last big idea of this chapter is on the effects of greenhouse gases. And like what I mentioned, this is the last final natural issue that we'll be talking about in this chapter. This refers to the gases, right, that traps heat and prevent it from escaping through the Earth's atmosphere. These are what I call greenhouse gases. They work like a greenhouse that's used to keep our plants in a warm, nice temperature, right? So for the greenhouse effect, there's actually two ways to look at it. Firstly, is about the importance or why it's so good about the greenhouse effect. Now, we must realize and acknowledge that without greenhouse effect, right, the Earth will be too cold for any form of life to survive in. So greenhouse effect actually allows us to have a habitable temperature that is suitable for living things. So as you can see in this diagram over here, right, when the sun ray hits the Earth's surface, some of it will be reflected off and some becomes heat. By having greenhouse gases around the atmosphere, such as carbon dioxide, as well as other gases like methane, right, it actually helps to trap the heat, so it keeps the Earth warm, and that is what we actually need for life to exist. However, the issue now is not so much about greenhouse effect, but rather that we have too much of it, right? Greenhouse effect by itself is actually okay, but having too much greenhouse gases, now we have a problem. Because the warming becomes so extensive, right, that we now have this issue that's called global warming. Because there's so much greenhouse gases that all the heat gets trapped within the atmosphere, and the earth is warming up at a rate that we have never seen before. And that causes a lot of other issues, like flooding, causing the polar animals to actually lose their habitats, etc. So this is actually a pressing environmental issue that we are facing right now. So in general, you realize that the chapter on air atmosphere actually requires you to read more widely about the different air pollutants, about the different environmental issues that can arise, like acid rain, ozone depletion, global warming, etc. Right? So this is a chapter that you will realize as we do the worksheets as well as the 10 series requires a lot of application of the knowledge. Alright? And with that, that's the end of the video. Thank you.